Hello and welcome everyone. In this day 19 learning of linked list, we are we have already completed circular linked list, and now we are going to be looking at certain interview type examples, interview type problems uh, with respect to linked list, right? So the first one that we are going to be looking at is going to be with respect to reversing a linked list, and we are going to be looking into how we do it for both uh, singly linked list and doubly linked list, and also uh, with combination of iterative and recursive way, right? So so we are going to be doing both for this, and also uh, so it will be possibly four questions, or maybe an interviewer might ask, how would you reverse a singly linked list either iteratively or recursively? So we can give this answer. I will quickly go through the code that I have here in JSPin. We can look at the code and quickly understand how the code would look like, right? Let's understand the key points, and then we can uh, come up to a solution or a thought process on how we can arrive at a solution. So first thing is, let's say we have a class singly linked list with uh, a value and a next pointer, and we know that the constructor will obviously starting with a value null. So we can insert values, print values, and here are the two methods that we are required to build: recursively and iteratively, right? So first, let's say we insert all these elements from the array, we print them. I will execute this. So first is the print statement, which gives us this result, and once we reverse iteratively with this method right here, we will go over these two methods. But yeah, just to understand what is being printed. So first we recursively reverse iteratively, so this gets reversed, and then recursively reversing this singly linked list gives back the original linked list that we had created. So let's go over these two key functions that are required as part of this problem, right? So we have already looked at insert and other uh, methods part of the linked list, either in singly linked list, circular linked list, or doubly linked list, right? So now it's time for us to look at how we can reverse a singly linked list. So first one is iteratively. So the easiest way that anybody can think about is, we can have three we can have a temporary storage with next node before we uh, swap it to the previous node, or let's say we store this as a next we store this current dot next as in a temporary variable called next node, and current dot next, which initially would be at null, uh, would be assigned here, and then we have the current pointer. We set the current. So it's little tricky. Maybe we will go to the drawing board here. Let me just go to the drawing board. So okay, so let's say we have a linked list 1, 2, 3, 4, 5. I will just draw it out here. So uh, so this is with respect to singly linked list, and uh, reverse iterative. So let's say we have 1, 2, 3, 4, 5, all pointing in a forward direction. So the best way to reverse iteratively, the thought process here would be, so first thing is we would start. with a previous value initially at null, and then we say current is equals to the head, and then we iterate recursively with while loop, and we say current is still the current is not equal to null, and we assign next node current dot next, and next uh, this current node we point it to the we reverse the pointer, and we also would assign this previous value with current, right? So that uh, we have the reference to the next node. So we current dot next. So first thing is, let's say we are here, we store this to this next node, and the current dot next, which is going to be pointed at null. So this is going to be pointed at null, and previous, which is equals to current, is going to be uh, pointed to this way, right? Previous is going to be pointed to the current. That's how this is going to be constructed. And let's say next current is equals to next node, and now again we are going to iterate, since the current is going to be 2. So we say current dot next node, which is equals to 3. So this 3, and current dot next is equals to previous was 2. So current dot next will be pointing to 3, and so on, this will go on. Little tricky to come to a thought process, but know that we need to have a temporary value to store the current dot next, and we also need a memory space to store the previous value, but it is all constant. So the time and space complexity here would be uh, of n, as we are iteratively recursing, and space complexity will be of 1. And the similar kind of thought process would be for doubly linked list, whereas let's look at recursive implementation in case of a singly linked list. So I'll switch back to the JS bin, and let's quickly see the code implementation that we had for iterative approach, and then again we will walk through the recursive approach. So as I said, we have a previous pointer, current pointer, which is this dot head, and then we have a temporary store for storage before we break anything with the current node, and we also would start swapping to the previous value, right? And we assign the previous value to the current node just to reverse the direction. Okay, so the reverse recursive function is going to have of n space complexity, as we are going to have a recursive recursion stack. So the way that, okay, let's switch back to the drawing board, but if you see, there are very minimal uh, lines here. So I will switch back to the drawing board, and let's try uh, having a proper thought process here, right? So, okay, so here in this drawing board, so now we are at recursive stage. So let's say we have a reverse of 1, 2, 3. These are the linked lists, and let's say we we would be this way, right? Verse 3, right? So what I'm doing here is I will write the function that we had. So the base case that we have here is, let's say if head is equals to null, head dot head is equals to null, or head dot next is equals to null, return head. Base case, this will be the base case that we see in uh, the implementation, and the new node that we are going to be building is reverse recursive. We are going to make a recursive call uh, to the next node, right? Head dot next, and we are going to reach the end of the node, and then we are going to assemble it back this way, right? New head dot next is equals to new head, or head, and head dot next is equals to null, right? So what we are doing here eventually is we are returning this new head, but uh, at the end we are also making sure that we swap the value uh, of the direction of the value with respect to this linked list, right? So let's look at the implementation. Okay, so first thing is the base case where we check if there is a node and if there is the next pointer, the next node associated to it. If there is none, then we return it. This is easy, which says if there is a node, then we return it. Else, we also check if there is next pointer, we return this, and recursively reverse the rest of the list. So we iterate recursively with the recursive function call here with all the next pointer values until we reach the end of the linked list. So at each time we take the current node and uh, we point it back to the we make the next pointer point it back to the current node, and also we break the link, right? So then when we are when this recursive call uh, recursive calls will act like a stack. Let's say we I will go back to this drawing board. So if you see, let's say we have 1 2 3. So every time we iterate this way, so we say here what we are doing. So hit dot next. So let's so this recursion stack will be established, and once we have that, then this piece of the function where we say head dot next, right? So first thing is we just return this head, and then once we are at here, this call gets made where we say head dot next 2.3 2 dot next changes to this one. So these are the two lines that changes those two values, where this being the head value gets assigned to uh, this value gets switched back to this one, and head, and this gets pointed to null, right? This gets pointed to null. And similarly, once we are at here, again this it's pointed to. So as you can see, first the recursion stack will be uh, created, and then we swap the pointers and also break the link between each pointer. Thereby, the recursion will be established. Have a little thought process. Please do let me know what would be the best way to think about this problem. Maybe you can post me in the comment section. While I will also show the doubly linked list recursion iteratively and recursively, I would also have this pasted in the comment section with the GitHub link, so you can go through this. So as I said, so we have previous node, we store just the previous node and we swap the nodes, right? And we iterate to the next node. We change the pointers from next to previous, right? uh, just have a thought process on how the singly linked list reverse function recursive function works. The same way you can build this function call up. So please do post me in the comment section about how you think about solving in recursive fashion, and I will have this GitHub link updated in the comment section. Hope you found this video helpful. Please do like and subscribe to my channel. Thank you.